Hello and welcome to my video on antiderivatives. An antiderivative is an inverse operation of differentiation. So recently, we have been given f of x and asked to find f prime of x. However, now we are given f prime of x and trying to solve for f of x, and that is an antiderivative. So the general formula for an antiderivative is this is the portion in which we are asked to find the antiderivative of, and this is our answer. We always use a capital F to denote an antiderivative, and we always add on C, which represents any constant because the derivative of any number is always going to be 0. So let's look at a simple practice problem. Here we are asked to find the antiderivative of x to the power of 4. So there is a formula for this, and here it is. We can plug in the numbers and we will get x to the power of 5 over 5 plus c. Now, we can check our answer by taking the derivative of the antiderivative and getting back x to the power of 4. And there it is. Now I will explain how this formula works, and we can prove that it works by taking the derivative of this answer portion and trying to get back to x to the power of n. So this can be rewritten as 1 over x plus 1 multiplied by x to the quantity of n plus 1 plus c. Because 1 over x plus 1 is a constant, we don't need to do anything to it in terms of differentiation. However, we need to take the derivative of x to the quantity of n plus 1, in which we get x to the power of n plus 1 minus 1 multiplied by n plus 1 plus 0. And you have to remember, taking the derivative of any constant by itself or any number like c is always going to equate to 0. So the n plus 1's cancel out, and what we're left with is x to the power of n. So these are additional formulas that you may need to know, and as you can see on the top, just like doing regular derivatives, you can take the antiderivative of each individual term. Now, most of these should be familiar to you because we've been learning to take the derivatives of many functions, and as I have stated before, doing the antiderivative is essentially just finding f of x given f prime. So there really isn't a need to memorize all these. They should be all familiar, and it's all about recognizing the derivative and attributing it back to the original function. Alright, cool. So in this problem, we are asked to find the antiderivative of 30x squared plus 5 divided by the quantity of 10x cubed plus 5x. So in this problem, I'll be using a technique called U substitution. So if you haven't noticed already, the top is the derivative of the bottom. So if we replace those values with U, it'll look something like this. Now, the derivative of U looks like the top portion. So now, from here, we can multiply both sides of this by dx and get
You may ask, why do we need to multiply both sides by dx? Well, if you look here at the original problem, there's a dx at the end, and we want to match this with this, so we can plug it back in and make it easier to visualize. So if we plug these values back in, we will get Does that look familiar to you? It should, because u prime over u is equivalent to, that is right, oh, my bad, to natural log of u. So, bringing all this back together, all we need to do now is plug in to plug in u back into natural log. And that's your answer.
Alright, so let's try a trig problem. So at first, you may not know where to start, and that is okay, but try to use what you know. And a good start might be trying cosine. So I know that the derivative of cosine is negative sine of x. So if I take the derivative of cosine of 2x, then I will get 2 times negative 2 times sine of 2x. Well, it's not quite the answer we were looking for, but it's pretty close. We've got the sine of 2x, right? We just need to get rid of the negative sign as well as the 2. So looking back at our original cosine of 2x, let's see what we can do to eliminate the negative 2. So one way we could look at it is adding a constant at the front. So if we try negative 1/2 cosine of 2x and then take the derivative of that, we will get negative 1/2 multiplied by negative sine of 2x multiplied by 2. And the negatives cancel out, and 1/2 multiplied by 2 equals 1. So in the end, we get sine of 2x, which is back to what it was asking us for. So the answer to this problem will be f of x is equal to negative 1/2 multiplied by cosine of 2x plus c.
As this lesson comes to a close, let's wrap up. So we know for an antiderivative, it's essentially saying, given f prime of x, find f of x. And some tips for solving these types of problems are recognizing your derivatives and using u substitution for it to be easier to visualize. In addition, don't forget to tack on your constants. Like in this problem over here, I was playing around with negative 1/2 to see if I could get to sine of 2x, and which I did. So don't be afraid to balance your equation using constants. Some common mistakes when solving antiderivatives is forgetting to add c at the end. In addition, many mistakes involving x to the power of negative 1. Like in this power rule, plugging negative 1 into n would be very disastrous. So always remember that x to the negative 1 is always 1 over x, which is natural log of x. Do not use the power rule for negative 1. In the end, subtracting 1 is also a big issue. Just like in this power rule, instead of adding 1, many students tend to subtract 1, being used to solving derivatives. But remember, you always add 1 when doing the antiderivative. So thank you so much for watching this video.